Hello, I'm RC Jim, and today I'd like to talk about battery chargers. Got the little Spektrum S1200, a little 12 volt supplied charger for a variety of batteries. Got the IMax B6, which is it does pretty well the same things, except this one is a smart charger, so it works with the Spektrum smart batteries and has a few features related to that. But boy, this is a great little workhorse. And this little guy is about half the price of one of those. Hence, you could just go out and buy two of those and get two batteries charged at once, as compared to the one. Of course, myself, I started out getting the politically correct Spektrum one, and then later on decided I wanted to charge multiple ones at a time, and I thought, well, I'll give these a try. So today we're going to go through them, show you how they work, advantages and disadvantages of each, and perhaps help you as you think about adding to your collection of battery chargers. Well, let's begin by having a look at our setup. We've got the two IMax chargers here. They come with a lead like this that you can plug in with banana plugs. 12 volt supply. You can buy a battery charger that has an end like that on it, little block that you plug into the wall. You can do that. But I originally had bought this 12 volt power supply and find that it works great. And I've soldered up these jumpers here to be able to do multiple batteries at a time. So we have the power that goes into each one of those. Each one has a red and a black wire, so black is neutral and goes into the black, and red is positive and it goes into the red. So we've got it all plugged in like so. With a Spektrum charger, it comes with this little jumper here. So you've got the IC3 connector, including the little smart conductor there in the middle. Again, with banana plugs on the end. So again, red and black, under red and black. So all of that's consistent. With this one, you do have to be careful in that you've got a IC3 male connector there, and an IC3 male connector here. This one is for the input, that one's for the output. So you need to make sure that you don't accidentally put the input into the output, okay? So that's the input of the power. So we're plugging that into the input. With this one, we're going to have an IC3 coming out to the battery. With these ones, we've got banana plug connectors going out to the battery. Okay, now one of the things that you want to think about, especially if you're using a single power supply like this to power a bunch of chargers, is to make sure you don't overdrive the power supply. So one of the things to think of right at the beginning is what sort of load am I going to have on this thing, and what's the capacity? Now, it's not enough just simply to look at the 20 amps that this says on here and say, oh, I'm only going to charge 3.5 amps, 3.5 amps, and 4 amps or something like that, and say that's plenty. Because it's going to be altering, this is going to be putting out 13.8 volts, but these things might be putting out 25 volts, depending on, how many cells your battery is. So, just for example, I've got some 6S batteries. They're 4,000 milliamp hours, so we could be charging them at 4 amps, but when I put 4 amps into this, it only charges at 3.5. Okay, a little anomaly, probably related to its own capacity, and it's smart enough to know what it can do, and it only does that. But anyway, let's say we got 25 volts at 3.5 amps. So what you need to do is pull out your handy-dandy little calculator, and say, okay, I'm going to have 25 volts times 3.5 amps. That's 87.5 watts. If I was to be doing 3 of those times 3, that's 262.5 watts. Well, how many watts is this thing? It's 13.8 volts at 20 amps. Well, the easiest thing to do is just simply to convert this into amps at 13.8 volts. So just simply divide by 13.8, and I'm good for 19 amps coming out of this if that was what the input was on all of these, and this is good for 20 amps. Now, I would say that's very marginal in that it might be 25.2 volts, it might be a little bit more than 3.5 amps and so forth. So I would not be doing 3 chargers all with 6S batteries on this. And certainly if you went to 8S and a large capacity battery, you'd be backing off. But given that I'm running both 4S and 6S's, I can easily be doing, say, a 4S at 2.2 amps over here and a couple of 6S's at 3.5 amps over there, and I'm well within the limits of what this can do. One advantage to having a 12-volt input is that you can hook it up to the car battery. So you just get yourself a little cable such as this with alligator clips on the end and your EC3 female connector on the other end. Connect that up to your car battery, plug that into your charger, and that works great. And for myself, when I'm on the road and at the field and I want to charge batteries, I'll be using this little guy along with that connector, and that works great. Could do that as well, but this is the one that I've got, so that's the one that I use. And it's not all of that often that I charge them at the field anyway, but we do have that capability. Now, as we're charging batteries, fire safety is always important. So I've got these metal plates that I keep down here that I'll have the batteries on. And I've also got a fire extinguisher handy nearby. So that's always an important factor. Naturally also, you always make sure that you stay in the location where the batteries are. So I work out here in the garage, and when I'm charging or discharging batteries, I'll be out here doing something else while that's going on, just to be able to respond quickly should something nasty happen. As you go to connect everything up, you'll find that you need a variety of connectors. Now, you might just want to solder up just exactly what you need, but I've got a great variety of batteries, and I use these connectors sometimes in the plane for a little one like that. Any of these ones with the banana plugs on only get used with a charger. But here you can see I got several things piggybacked to get me to the right voltage. I wouldn't do that type of thing if that was in an airplane, but when it's just a charger, if there's losses or whatever, it's not a big deal. Okay, so you always have power going to the main power leads of the battery, and you also have a balance lead. Now here's where there's a difference between the IMax and the Spektrum. The Spektrum just simply has one place to connect a balance lead, and the earth is down at this end at the bottom. With the IMax, you got a separate spot to plug in each different battery cell number. So you got a 2S, 3S, 4S, 5S, and 6S that you could possibly plug into there. So in this particular case, we got a 6S, so we're plugging into the 6S spot. And so obviously if you had an 8S, you'd be using a different charger, not this one. So that's something else to think of along the way. Yeah, so we're talking about the Spektrum or the IMax. Either one is 6S maximum in terms of what it can handle. Okay, so we got our main power hooked up. We got our balance connector hooked up. We got another one here. This one I do happen to have the right connector. We make sure the red goes to the red and the black goes to the black. Rather important. We connect up our battery, and let's get things on the middle here. Okay, connect our battery to the power, and we connect the balance lead to the balance port. Okay, so that one's all set. We're going to use this watt meter here in a minute. Okay, now we got a 4S here, and of course you're familiar with 4S, 4 cells, as you can see there, as compared to 6S with 6 cells in there. Other than that, very similar. That one is 4,000 milliamp hours. This one's 3,300. But anyway, with this one, yeah, I just need this little guy here to do an adapter. That, by the way, is an EC3 connector. And the EC3 connector is basically compatible With the IC3, it just doesn't have the little extra conductor for the smart stuff. So it'll plug in there. That plugs in rather loose, you know, so I always get a little bit concerned if I'm talking about something in the plane using the EC3 with the IC3. But depending which way you go, it might be a tiny bit loose or it might be extremely tight. If it's extremely tight, that doesn't bother me, but something like this would be a little bit of a concern. That pulls out pretty easy. And you also wonder about what sort of conduction it has as compared to like when I plugged in this XT60. That was a really nice firm sort of push, and that would be very consistent. Okay, so I mentioned with this Spektrum that the negative is at the bottom. The negative is at the opposite end with this, and of course the way you tell the negative is you've got one red wire and you got a bunch of black wires. The red wire is what we think of as a positive end. The black wire is what we think of as a negative end. In actual fact, each one of those is going to one of the junctions between the cells to monitor the voltage at each place where a cell is connected together. But nonetheless, all you need to worry about is the red is going to go from the end away from the negative end. So on this one, it's going to that side. With this one, it's going to that side. There's also little tabs on the battery to make sure it only goes in the right way, which is the type of thing we like to see. Now, I mentioned a minute ago that I was a little bit concerned that I wouldn't want to use 3 6S batteries with this charger. So I thought, well, hey, why don't we get out our watt meter and just see if what I said is true. Okay, so I got red to red, black to black. Okay, and that's on the source, so that's the power source. Load, that's where the current is going to, and so I plug that into here. And we're going to fire this thing up, and we're going to see what kind of amperage it's drawing and whether it's within what that's supposed to be. Okay, so that will happen here in a minute. But now we need to go through what are the procedures that you use in getting these things started. Each one is a little bit different. Yeah, okay, we got to go ahead and power it up, don't we, to be able to do this. We're powering it up. Right now, 0.33 amps, quite safe. Nothing has started up yet. You know, that's just the base load. Okay, so with the Spektrum Smart Charger, menu, press and hold. Okay, so you hold down that, and that gives you the menu. That's the main menu. And so you can see what type of battery it is. It's a LiPo. How many cells does it have? This is a 4S. I don't need to change that. But if I did want to change that, I would go to that. I would press the button, and then I can dial on the outside of this to get what the selection is that I want. So I want 4S, so I select that. We got 4S. 3.3 amps. What you do is you take the milliamp hours and divide that by 1,000, which gives you amp hours, 3.3 amp hours, and that's the number of amps that you should be charging a battery at. That's what we call a 1S level. Okay, so 1S is 1 times the amp hours in amps. Okay, so what the battery capacity would be if it delivered all the power over 1 hour. Okay, so 3.3 amps is the maximum that you should go with this. Some people go beyond that, but that is likely going to reduce the life of your battery to do that. 4.2 volts per cell is the maximum voltage for a LiPo battery. So that's always going to be 4.2. Now, you might be aware that 3.7 is the nominal voltage per cell. That's kind of what you're getting down to. That's close to the bottom end of the range. But 4.2 is the top end, and that's what this is specifying. Now, it could start it right away, but there's also some other things in here. Smart battery settings, we won't worry about those. That has to do with the Spektrum battery. But on the system settings here, you've got input voltage. Now what that input voltage is going to do, and this is something that this charger has that those don't, is that this thing is going to shut down if the input voltage goes below that. So if you're using this with your car and you've got that, you know, you're not running the car, you got the car battery tiny bit over 12 volts. If you set that at 12 volts, if it draws the current down, or draws the battery voltage down to be below 12 volts, it'll cut it off. And at 12 volts, your battery ought to be able to start your car. Certainly it's done with me. I've had it happen. I've had it cut out on me and say, oh, thank you for doing that. You know, I didn't want to get stranded out here. Yeah, it safely cut it off when the battery got down to 12 volts and the car easily started after that. So in this particular case, this is delivering 13.8 volts, so I want something just below that. So I've got it set at 13.5. Input power, 180 watts, that's what it's capable of doing. As we've mentioned here, we've got about 280, 290 watts, something like that, that's capable of. But it's just saying that's what you'd need if this thing is going full blast. It's got backlight, volume, and various things like that. Oh, you got this touch sensitivity on here. I've got it set on low. That's how sensitive this thing is in going around. And this is a bit dodgy, so I kind of like to have it on the low setting and let it be patient rather than going all over the place. Okay, and the auto charge is on to where if you had a Spektrum battery that's a smart battery, it's just going to automatically start charging it because it already knows what it is. Got a self-test feature there, calibration. But then to go back, we just hit back, and now we're ready for this to start. And so we press start, and it says that it's got a LiPo 4S. It's at a 40% level right now. It's gradually moving up on the charge rate, gradually moving up to that 3.3 amps, or you'll find it might go 3.3, 3.2 sort of a thing. Telling us how much of a charge has been added. So that's not the charge that the battery is currently holding, it's how much the charger is added during this particular session. And then it tells you how long it's been going in this particular session. And with all of these chargers, you can set a maximum to where it would automatically turn off at a certain time if you're worried about potential of the thing going bananas or whatever. Okay, now with the IMax, we've got a few more things to do. One of the very important things is that it starts out just simply saying LiPo charge. And what we want is we want a balance charge. And so that's actually not the default setting. You've got to actually, you got this decrease, increase button here. So you press this and this goes through the various choices that you've got. And we want a balance charge. And of course what the balance is doing is it's making sure every one of these 6 cells is getting charged equally. It's not letting one hog all of the current and end up getting overcharged. It's going to be looking at the voltage on each cell to make sure it gets balanced equally. Okay, we then, as we press the start enter button, it goes through the other options that we've got. So we can set the amperage. This is 4,000 milliamps, so that would be 4 amps, would be a 1S level. So 4 amps is what it can handle. We got the increase, decrease to be able to change that. Hit the enter to go to the next item. And with this, as you go through the menu selection, it's going 4S, 5S, 6S, and we've got a 6S here. So we have a look, we've got a LiPo battery, that's the battery type. We got a balanced charge is what we want to do, 4 amps, which is right, 6S battery. So now we push start and we hold it in until it says battery check. And now it's checking to make sure we put in the right parameters. It's looking at the balance connector and it says we got a 6S battery. And it says you said that we had a 6S battery, is that right? And if it is, you hit the start button and it starts to charge. Okay, so we just checked to what we've got. We got a LiPo 6S battery. It's being charged at 3.3 amps, which is a little bit less than the 4, but that's fine. Right now it's at 24 volts. That's a balanced charge that's happening. That's the time that's elapsed and this is the amount of charge that has been put into it. So very similar as far as all of those things are concerned. As we look at our meter here, with two of these things going, we see we're running at 10 amps. So this is capable of handling 20. With two of them going, we're at 10. So far so good. Okay, so now we got our last 6S battery here. Right now it says LiPo charge 2.2 amps, 4.8 volts. What's wrong with that? Well, everything except LiPo. So, first off, we don't want charge, we want balance. We go to balance. Secondly, we go to the enter. Okay, now it's just jumped up to 4 amps. It probably remembers that I did that the last time. And now all of a sudden it's decided, yeah, we really have a 6S battery, so that's corrected itself as well. But if any of those things wasn't right, you'd use the increase-decrease thing to do that. Once we see that everything is correct, then we hold in the start enter button until it comes up with the battery check. It says 6S, yes, that's right. We hit the start to confirm it, and now it gets going again for us. And we have a look at our watt meter, and we're now around 10 amps still. Gradually increasing, 11 amps, 12 amps, 13, 16, 11, and wow, input voltage lower than 13.5. So that shows you what happens here. Probably this thing is adding something in there. What we will do, just for kicks, I'm going to turn this off. I'm going to take this out because you see these little wires here. Those are made for charging a single battery, not for powering the whole system. And as you can see, all of my other cables in here are all nice heavy ones. So let's pull that out, put this back in here, and this will be a good lesson in electrical resistance. Okay, so we're going to turn that back on again, and so now we have to get everything started all over. Okay, so menu, press and hold. LiPo 4S, 3.3 amps, 4.2 volts, that's right. Hit start. That's good. Okay, LiPo charge. We don't want charge, we want balance. 4 amps, 22.2 volts, 6S, all of that's correct. So now we hold the button in, and that starts. LiPo charge isn't right, we want balance, so we go to balance. 4 amps, 22.2 volts, 6S, that's all correct, so we hold in the start. Battery check, enter, and we confirm this one as well. And now we will see whether this thing complains about the input voltage going too low. And I dare say I don't think it's going to do it because I've charged it with the setup before. Okay, so this one's up to 3.4 amps, that one's at 3.3 amps, this one's at 3.2 amps. No problem at all. This is saying, you know, the voltage hasn't gone too low. So essentially what's happened is, you think about any set of gear like this, you've got resistance in these small wires, and that in itself probably wasn't enough to do it, but there'd also be some resistance in the watt meter itself. Every connection that you add has got a little bit of resistance in it, and when you get that current flowing through there, if you get, you know, 15 amps or so of current going through there, that's quite a bit, and a little bit of resistance can cause a voltage drop. And so this was detecting that there was enough of a voltage drop to take it from 13.8 volts there to just below 13.5 volts over here, and so it gave you that warning. Okay, so that's the setup as far as charging goes. Now, these chargers have got a variety of other functions as well. So let's just, well, first off, if you want to stop, these buttons, these chargers have got a button on the end that says stop, battery type and stop. So if you hit stop, it'll stop it. So we'll just stop both of those. Okay, this one here, you've got to press in the menu and hold. And then you've got a stop selection that you can choose. So we press that, and that stops that. Okay, now we've been flying, and so I'm ready to store these batteries today. Had a good time, by the way. I flew the Super Air for the first time on Success Electric. It used to be a glow fuel nitro motor, and boy, did that thing fly nice. But anyway, we want to store the batteries ideally at 3.5 volts per cell. But anyway, sorry, not 3.5, 3.85 volts per cell, get that right. But basically between 3.8 and 3.9 is going to be acceptable. So this one right here is 3.868 volts per cell for that one. And of course they're all going to be pretty similar to that. So that one's fine. It's at 53%, so that's good for storage. I'll set that one up there. We'll have a look at this one. And keep in mind, on this particular thing, it's like these guys, and the negative is at the top. You can always tell is you got the little indentations up there for the little indentations on the plug. Those are just on one side. So the side with the indentations is where it goes. And so anyway, this one is at 84%, 4 volts per cell. So that's too high. I want to take that one down. Now, there's a couple of ways that I could do that, and the charger is one of those ways. So you can plug it into the charger, and as you look at your menu right at the start, before anything's blinking, use the decrease-increase buttons to go from fast charge to storage, okay? You don't worry about the amps. It's not going to do that level of amps anyway, most likely. And it'll probably just be at 2. But you make sure it knows what kind of battery it is, Success. So you say that's right. You hold in the button, and does the battery check. You say, yeah, that's what it is. And now it's actually going to draw current out of the battery because it's got too much. And so it's saying right now it's drawing 0.3 of an amp. And remember, it had said 2 amps. I don't think it's going to get it to that, but 300 milliamps is what it's drawing, and it'll keep drawing that until it gets down to around that 3.85 volts per cell. Now, these chargers do act a little bit different in terms of that storage level. The Spektrum charger seems to like it at a slightly lower level than these ones. These ones are pretty well spot on as to what it ought to be. With the Spektrum charger, I think it tends to go a little bit low. In fact, just to try that out, let's put this guy back on here. You remember this was 3.86. Check that again. Okay, 3.865. Okay, so we're saying that's fine. Let's see what the charger thinks. This one, of course, is upside down, so negative at the bottom. So we've got the same sort of thing here. So we actually go up to the top of this menu where it says Task. Right now it says Charge. So you hit Enter to be able to pick the choices. You got Charge, Discharge, and Storage. Now, discharge is not going to totally discharge the battery, but it'll discharge it as far as the thing will allow. So it's not good enough if you're disposing of a battery to discharge it. But what we want is a storage. So we hit the storage. That's the task that we want. And let's just see, by the way, whether we've got a storage voltage in here. Input, voltage, completion, tone, touch sensitivity, language, auto charge, self-test, calibration. No, we don't have a storage voltage. I didn't think there was, but I thought it'd be worth checking. Okay, so just checking back here. Task is storage. It's LiPo. It's 4S. Current, it's saying 3.2 amps. That's not going to be a problem one way or the other. It won't go that high. So we say start, and it's discharging the battery. So even though this battery is fine and it's nearly ideal where it's at, the Spektrum charger wants to discharge it lower than that. So we'll leave that on. We'll see how far that goes. But keep in mind with either of these things that they are going to go really, really slow. So let's look at another method. Okay, our chargers are plugging away, trying to discharge these batteries at a mammoth rate of 0.3 amps each, which is ridiculous. You think about it, in your airplane, they're probably drawing, what, 20 amps? And these things are drawing 0.3, you know. This one is obviously running a fan, and that takes 0.3 amps. That one's probably running it through a resistor because I don't hear anything. Just very mildly warm. So that's that. But one other way to do it, and this still isn't necessarily what I would do all the time, but it's something you could do. This is a little rig that I've put together for discharging batteries when we're going to dispose of them, because you always want to fully discharge your battery before you dispose of it. So I just got some auto globes and some sockets wired together, and I can hook it up either parallel or series or whatever I want. But with a 6S battery, you know, I'm thinking, you know, run them all in series to minimize the voltage on each one. So let's just see what sort of amperage we can get out of it. Now we'll keep in mind we've added a little bit of resistance with this, so the actual amperage is going to be a smidgen more. But we've got our watt meter there hooked up to the power. Red and black means nothing with this. It's just simply electricity is going through and coming back. They're not LEDs, so it makes no difference as to polarity. So plug in one to one and the other to the other, and voila, we light up the lights. And it's discharging at 1.33 amps. So that's 4 times the rate of what that one's doing. So this would take 1/4 the time of what that is. But there's still another method yet again, and that's hanging up here behind me. I've got this little test rig that I use for testing motors and ESCs and so forth. And you could use something like this, or you could use one of your airplanes, put the battery in it, you know, rig it up to where it's not going to fly away on you, and run it at half throttle or something like that for your 5 minutes, or you know, whatever it might take, and the job is done. So that, most of the time, that's the type of thing that I do. I don't know if it makes any difference in terms of battery longevity, whether, you know, the battery has been run in the plane and brought down to its storage level, or whether it's been brought down extremely slowly with either a charger or some globes such as this. But certainly they all will bring you down to that particular level. Now, each of these chargers have got a variety of other tricks and gimmicks that they do. Of course, you always get a instruction booklet, you know, with it when they come, and it's got all your warnings about the lithium and all that kind of stuff. So certainly pay attention to that. Gives you a flow chart in terms of how the program works. I tell you, it's not intuitively obvious when you look at this as to what you do there. So what I've showed you there is what you need to know as far as how you do it. There are some things down here in the menu where you can set, like the safety timer, the capacity cutoff, so you could set it for a certain maximum amount of time and then it's going to stop. Or you could set it for having put a certain amount of energy into the battery and cause it to stop. Those would be both fail-safe devices, so you realize that the capacity of this is 4,000 milliamp hours. So you could set that to say 4,000 and say if it goes over 4,000, definitely stop. You know, something is wrong. Myself, I don't worry about those things because I'm with the thing all the time and I'm periodically checking as to how it's going. Like this one right now is down to 24.22 volts. If it was going the other way, I'd be looking closely at that, and I'd also be looking at the amperage. And that amperage will gradually go down as it gets closer to the target. Naturally, what's happening if this was charging it, what would be happening is this voltage would be artificially high, because in order to get the amps to go through it, it has to go to a higher voltage than where the battery presently is. So if you were to stop it and then look at what the voltage is, in the charging situation, then the voltage of the battery would actually be lower than what it's showing on the charger. The charger, that's the charging voltage that you're looking at. And by the way, if you're using something like the airplane or the test rig to discharge it, what I will do is I'll have the little meter plugged into it while that's happening, and I'll be monitoring it. But the same sort of thing is happening in reverse there. When the motor is running, it's pulling down the battery. You've got a voltage drop going through the battery because of its internal resistance, and so it's going to show a lower voltage on the meter than the resting voltage of the battery after the current stops. So if I'm shooting 3.85 volts, I'll certainly be down slightly below 3.8 with the motor running. I'll get down to that level. I'll then turn it off. The voltage will come up, and it won't come up instantly. It's sort of a slow recovery. So you give it 10-15 seconds to sort of come back to a steady state. You see what it is. If it's pretty close to your target range, then everything is fine. Okay, so you've got the safety timer, you've got the capacity cutoff, can turn the buzzer on and off. You've got input power low cutoff, so the same thing that I mentioned with this, you can set that on that one as well. I don't know what this waster time is. You got a temperature cutoff. That takes a special thermocouple that you plug into the charger someplace. I don't have one. Yeah, over here, temperature sensor. So you got a USB connector for the temperature sensor. These are all just cooling holes except for that middle one on this side. And that, well, I say a USB, it looks kind of like a servo connector. But anyway, if you had a thermocouple that you had hooked up to the battery, you could have it on there. That could be another fail-safe thing to cut it off if it gets hot. Let's see, what else you got? Yeah, the battery type, that's done right at the start. But again, with that, you're just going to have it on LiPo, and it's probably coming that way. So all of those neat little things it can do. So it goes through the various things to get into what you want to do. Oh, on the cutoff as far as the input voltage on these ones, while you can set it, I've got a note on here that's 11 volts maximum. So that's basically useless. If your power supply gets down to 11 volts, you got a problem. Your car's not going to start. You've probably burned up something or whatever else. So don't worry about trying to set the input voltage safety thing on that, and depend on it. Okay, so basically that's everything that you need to know. These are balance chargers. They will do a balance charge, and it also is keeping track of the balancing and discharge. Same thing with the Spektrum. What the Spektrum battery will do that these won't is if you have a Spektrum battery that's a smart battery, you can plug it into this, and it's going to automatically detect what it is and just simply start charging it. So it saves you a few steps on getting the thing going. But apart from that, I can't tell that it does anything extra special. So I'm very happy to spend less money and use something like this. But that's what it's all about. We note here that we are still discharging here. It says it's down to 47%. I'm just going to stop it here, and we will have a look at what we've gotten to. Okay, it's taken down to 3.84. Now 3.85 is the ideal voltage. This thing is keeping on going. I don't know what they're thinking of, in doing that. Whereas I think you'd find with this guy here, it's going to stop probably just a little bit above 3.85. So this one is way low. This one is within what you would expect. Certainly very acceptable, and neither one seems to be absolutely precise as to exactly what we want. But as we said, between 3.8 and 3.9 I think is acceptable. But this guy here, I think many times it'll end up saying it's all done when it's well below 3.8. Just one more thought as we think about using a motor to run down your battery and get it where you want it. And that is, you don't have to use a receiver with your ESC and motor to run it. If you've got a capacity meter like this GT Power 8S battery capacity meter, this is actually something that will run a servo as well. And of course the servo output is the same as the sort of output for controlling the motor. So what you do is this middle button that says cell on the big part of it, and servo underneath it, which is kind of hard to read. But anyway, you'll be holding that down, but you put your normal power in here. You'd normally expect 5 to 6 volts. This one's 6.5 volts, but close enough. So anyway, your power goes in there, negative terminals at the top. You put your signal cable over here, the one going to the ESC, the negative terminal is at the bottom, and on this it's marked in the plastic there if you look carefully. You then hold down the cell button or servo, and you can see that that's got 1,000 millihertz or whatever it is, microseconds, 1,000 microseconds as far as the signal that's being sent. Right now I've got this unplugged. So anyway, you should dial up the dial on the side of it. It goes up to 2,000. So that's your range for servos. It's going from 1,000 to 2,000 for most of them anyway. So we got it on the 1,000, so that's equivalent to having the motor turned off. We get the power hooked up, so we make sure that our prop is clear. We make sure we are secured so it can't go anywhere. We plug her in, and then once it's plugged in, we can just simply turn the dial on the side, and lo and behold, the motor runs. So whatever you decide to run it at. Okay. Now the only downside to that is that it doesn't tell you what the voltage is for the battery. So that's a downside to it. Type, there we go. Hitting this first button is what takes it out of the thing. And of course right now my ESC is telling me we got a throttle fault. That single beep that gets repeated, that says that there's a throttle fault, which this is what we call a throttle fault if the cable's disconnected. But what I'm wondering about is that, okay, everything's still safe. If I have this plugged in, is that going to tell me what the voltage is for that? I'm going to disconnect that. 6.144. Well, that doesn't really help us a lot because that's the battery elimination circuit that's telling us 6 volts. So that is what should be there. Good question though as to whether that would be adequate to power this thing. Learn something new every day. You don't even need this battery. The battery elimination circuit on the ESC is actually powering up the meter, and so without anything at all you can simply plug it in and off you go. Okay, so discovering new things all the time. Trust that that's helpful. Well, that should cover it for today with regard to battery chargers. If you do have questions and wonder about what to do about this, that, or the other thing, please add it into the comments down below. I respond to all of those, and oftentimes they will be the inspiration for the next video that comes along. So feel free to ask. I'm very happy to help you out with regard to information and things such as that. If you like what you're seeing on our channel, please subscribe. That helps us, and I trust it'll help you as well, as you have all of these things right at your fingertips and ready to be able to go back and refer to things and remind yourself about stuff, and even just enjoy watching some of the flying. Got lots of good things along the way, so stay tuned and we'll be telling you more. I'm RC Jim, signing off. Happy flying.